In this video, we will discuss about a question from Gate 2006 based on stack for the preparation of Assistant Professor Computer Science, Computer Instructor Grade 1 and HSST Computer Science. So let's see the question. An implementation of a queue using two stacks S1 and S2 is given below. So what is queue? Queue is a FIFO data structure, and that means first in first out, and we know that in queue we will insert the element at the rear position and delete the element from the front position. Suppose I am pushing 1 2 3 4 into a queue, okay, at the rear end. This is rear end and this is front end, okay. So when I push this 1 at the rear end, I will push. Then when I insert 2, this 1 will push to front. Then when I insert 3, this will come, 1 will move to this position. So after, suppose I am planning to, if I am planning to insert 4 elements, what will be the situation? 1 will be here, 2, 3, 4, suppose 5 is there. So the first element which we have pushed is at the front end. Whenever we delete something from queue, first of all this 1 will be deleted, then 2 will be deleted, like this, okay. So that this NQ and DQ operations, or insert or delete in queue operations, has to be implemented by using stack. So for the for the insert operation, how we implement it is using stack, that is by just pushing the elements. Whenever we insert an element to the queue, we will push the element into the top of the stack. Whenever we push next element at the rear end, we will push the element at the top of the stack. Like that we can implement, okay. That means for the insertion operation, for each element for the insertion of each element, we need push in the stack. That means if n insertions are there, we have n pushes are required to implement this insert operation of queue using stack. But in the case of delete, we are going to delete from the front end. That means whenever we perform an DQ operation or delete operation in the queue, the first element which we are going to delete is 1. But to delete this 1 in using stack, 1 is at the bottom of the stack. But in stack we can perform the pop operation, that is delete operation, only on the top of the stack. But 1 is not at the top of the stack. So we need one more stack, so that we will pop this 5 from here and push this 5 to here, okay. That means one pop and one push is required. Then 4 will be popped, 4 will be pushed, 3 will be popped, 3 is pushed, 2 will be popped, 2 is pushed, finally 1 is popped and 1 is inserted. Now 1 is at the top of the stack. Now you can pop. So for a single delete operation, for the first single delete operation, we had required n pop, for each delete operation we require one pop, push, next pop, push, next pop, push, okay. So for a single delete operation we need one pop, then push, pop, push, okay. Then whenever this element to be deleted comes at the top of the stack, we will perform the pop. So this pop is performed. So for each delete we need 2 pop and 1 push, okay. And for insertion we need only, for a single insertion we need only 1 push, no pop is required. So this is the way how queue is implemented using 2 stack. Now come to the question. Let n insert and m less than or equal to n delete operations be performed in an arbitrary order on an empty queue Q. N insertions are to be performed in the queue, okay. So how many pushes or n insertions and m less than or equal to n delete, okay. M can be up to delete or less than delete, okay. So maximum, if we are inserting n elements into the queue, the maximum number that can be deleted is m. The number of deletions are represented as m, and the maximum number of deletions possible are n. That is why less than or equal to n. Okay. Now, let x and y be the number of push and pop operations performed respectively in the process. Which one of the following is true for all m and n? That means n insertions are there in the queue, and m deletions are there in the queue. So, for n insertions, how many pushes and pops are required in stack, and for m deletions, how many pushes and pops are required in the stack? That is what is the question. So, let me explain that. Okay. So, we have a best case and worst case are there in this question. In the case of best case, how does insertions and deletions in the queue is performed, and in the stack corresponding stack operations. So, the best case is alternative insertions and deletes. Okay, so this is queue structure, and we have two stacks here, stack 1 and stack 2. Okay, so for a single insertion, suppose I am inserting an element 1, I will push this element to the stack 1. So single insertion requires single pushes. So for n insertion, how many pushes are there? It is n pushes. N pushes. Okay. Now, in order to delete, I need, suppose if I want to delete this one from alternative pushes, insertions and deletions. So one is inserted, now I am going to delete this element. So it is just deleting this element from queue. But whenever we use this whenever we implement this using stack, first of all, pop this element from stack 1 and push it into stack 2. Okay, so pop this element, so and push this element, then pop. That means for deletion, okay, single deletion, for single deletion, we required one push and 2 pop. Okay, 1 push and 2 pop. So, for deletion, m deletions are there. Okay, m deletions. So, for a single deletion, 1 push and 2 pop. That means for m deletions, m push and 2 m pop. Okay, so what is total? For insertions and deletions, what is total? It is n plus m push and 2 m pop. Okay, so this is the best case. In worst case, so let's see worst case. So worst case means insert n number of elements to the queue first, then delete m elements. Okay, so I have queue here. Okay, so and I have two stacks here. Okay, when I push this 1, I will push the 1 to the stack S1. Then when I push this 2, okay, I push this 1, and when I insert 3, okay, I inserted 3, then 4, so 4 is inserted. That means in the worst case, for each insertion, I need one single push. So n insertions require n push. Okay. Now, what about the delete operation? So, whenever we perform delete operation in the queue, the element which are going to be deleted first is 1. But whenever we use the stack, in order to delete this 1, we have a process. What is it? So, first of all, 4 will popped, 4 will be pushed, 1 push and pop. 3 will be popped, 3 will be pushed. Again, now 2 pop and 2 push. Okay, then 3 pop and 3 push. Okay, 4 pop and 4 push. Okay, now we will delete this one from the top of the stack. Okay, so that means 4 pop and 4 push, and finally last pop. That means for the first deletion, for the first element deletion, we need n pops, okay, plus n pushes, okay, then plus one more pop, the last one more pop. Okay, this is for the case of first deletion. For the second deletion, I will just delete this 2. Okay, now I am also just deleting this 2 from the top of the stack. That means for the remaining deletions, we need only one pop. So, suppose we have m deletions, okay, then what will happen? We will have m minus 1 pops. For the first deletion, we have n pops plus n pushes plus 1 pop. For the remaining m minus 1 deletions, we have m minus 1 pops. Okay, so for the case of all the elements deletions, this is what the number of pushes and number of pops. So, for the total number of pushes, for the insertion and deletions together, we have n pushes here. Okay, so n pushes plus here also we have, so for the m deletions, okay, here also we have n pushes. So, 2n pushes, okay, then number of pops, how many number of pops? Here n pops, then here 1 pop, then m minus 1 pop. That means this minus 1 and this plus 1 cancel. So, n plus m pops. That means m plus n pops. Okay. So, for the best case, we need 2n pushes and m plus n pops. So, the push operation is represented as x in the question. So, x may vary from, for the best case we need only n plus m push. So, n plus m push, and in the worst case we require 2n pushes. Okay. Then for the number of pops we require variable y, and how many pops here? It is 2m. So, 2m pops are required, and how many pops in the worst case? M plus n. Okay. So, this is the answer, n plus m less than or equal to x less than 2n, and 2m less than or equal to y less than or equal to m plus n. This will be the solution. Thank you.